Welcome to this presentation on the mid-latitude regions and deserts of the world. In this video and PowerPoint, we will explore two major biome groups, the mid-latitude biomes and the desert biomes, focusing on where they are found, their key characteristics, and how life has adapted to these environments. While deserts are known for their extreme aridity, mid-latitude biomes are characterized by distinct seasons and moderate rainfall. Together, they cover vast portions of the Earth's surface and play crucial roles in global climate regulation, biodiversity, and human activity. By the end of this session, you will understand how location, climate, and soil processes shape these contrasting environments. The world's ecosystems can be grouped into large ecological zones called biomes, each defined by its climate, vegetation, and soil. In this part of the course, we focus on biomes that belong to the mid-latitude and desert zones. These include mid-latitude grasslands, broadleaf and mixed forests, and both hot and cold deserts. Each biome represents a balance between temperature, precipitation, and biological adaptation. Understanding how these factors interact helps explain global patterns of vegetation and land use, from the fertile prairies and European forests to the harsh, arid landscapes of the Sahara and Gobi deserts. Deserts are primarily located between 20 degrees and 30 degrees latitude north and south of the equator, within the subtropical high-pressure belts. Here, descending dry air from the Hadley cells suppresses cloud formation and rainfall, resulting in arid climates. Some deserts, such as the Sahara and Arabian Desert, are hot year-round, while others, like the Gobi or Patagonian Desert, are cold but still very dry. This pattern shows that latitude and atmospheric circulation are key controls on biome distribution. Inland position, rain shadows, and ocean currents also influence desert formation and moisture availability. Desert soils, known as aridosols, are typically dry, thin, and poorly developed due to limited weathering and organic activity. They have a light color, low organic matter, and often contain calcium carbonate or salt crusts near the surface. The lack of vegetation and rainfall means nutrients accumulate rather than leach away, forming hard layers called caliche. Although generally infertile, these soils can support specialized plants and, with irrigation, can be used for agriculture. Understanding aridosols is key to studying desert geomorphology, as soil formation here is slow and strongly influenced by wind and occasional flash floods. Many people imagine deserts as endless sand dunes with no life, but this is a misconception. Deserts can be rocky, gravelly, or even icy, and they exist on every continent. They are not lifeless. Plants like cacti, succulents, and shrubs, as well as reptiles, mammals, and insects, are highly adapted to the environment. Another myth is that deserts never receive rain. In fact, they do, but less than 250 millimeters per year, often in sudden intense storms. Finally, not all deserts are hot. Cold deserts like the Gobi and Antarctic Desert also meet the definition of extreme aridity. These facts show that deserts are diverse and ecologically important. Mid-latitude grasslands occur in the interior regions of continents, typically between 30 degrees and 50 degrees latitude. Examples include the North American prairies, the Eurasian steppe, and the Argentine pampas. They experience warm summers, cold winters, and moderate but seasonal rainfall, enough to support grasses but not dense forests. Periodic fires and grazing maintain the open landscape. The dominant soils are mollisols, which are deep, dark, and rich in organic matter from decaying grass roots. These fertile soils make mid-latitude grasslands some of the world's most productive agricultural regions. Plants in both deserts and mid-latitude grasslands show remarkable adaptations to their climates. In deserts, plants often have small or waxy leaves, thick stems, and deep root systems to conserve water. Some, like cacti, store moisture in their tissues, while others remain dormant until rare rains occur. In grasslands, plants have extensive root networks that help them survive fires, droughts, and grazing. These roots also enrich the soil with organic material, promoting fertility. Together, these adaptations illustrate how vegetation structure is closely tied to water availability and temperature extremes. The mid-latitude broadleaf and mixed forest biome is found between 30 degrees and 60 degrees latitude in eastern North America, Europe, and East Asia. It experiences 4 distinct seasons and moderate precipitation throughout the year. Vegetation includes deciduous trees such as oak, maple, and beech, often mixed with conifers like pine and spruce. Leaf shedding in autumn returns nutrients to the soil, supporting a rich forest floor and diverse fauna. These regions have long been centers of human settlement, agriculture, and timber production due to their fertile soils and moderate climate. The dominant soils in mid-latitude forests are alpha soils and ultisols. Alpha soils are fertile and moderately leached, with well-developed horizons and a clay-enriched subsoil. They support much of the agriculture in temperate regions. Ultisols are more weathered and acidic, found in warmer and wetter areas, such as the southeastern U.S. or southern China. In some transitional or clay-rich zones, vertisols also occur. These soils have high clay content, causing them to swell when wet and crack when dry. Examples include parts of southeastern North America, southern China, and eastern Australia. Although difficult to manage, vertisols can still support forest growth where rainfall is sufficient.